Mr. K online.
Hi guys and welcome to Science. Today you are going to be learning about something that's all around you, you experience every day, maybe you don't notice it. It's called surface tension. Let's get things underway. The first thing I want to talk to you about today is something that will help you understand today's experiments and what's happening in them. It's called a molecule. Now, a molecule is when two or more atoms join together. Now, molecules are the basic building blocks of any material and give that material its characteristics. For example, Urkel is made of plastic and he's made of billions and trillions of molecules, because molecules, once again, are super small, like atoms, but a little bit bigger. And that molecule, the plastic molecule, actually gives Urkel's plastic body the characteristic of being a little bit soft and a little bit flexible. See that? Yeah, cool. Yeah. So, molecules, basic building blocks, give things their characteristics. Okay. Now, next to me, you can actually see one of the molecules that we're going to be dealing with today in our experiments, and it's the water molecule. And as you can see, it's made up of 3 atoms. Now, those 3 atoms are 2 hydrogen atoms, which are the little white atoms that you can see there, the balls, and then there's also the oxygen atom, which is the red ball. So it's made up of 3 atoms, and the combination together gives water its characteristic of, well, being a liquid, which means when you touch it, it changes shape, and you can drink it, of course. Okay, so water molecule, and that's what we'll be using today and looking at. Beyond that, there's the diagram next to it, and that shows basically that light molecules, like water, are attracted to each other and bond together, which helps us be able to see these materials, because a lot of molecules are so small that we can't see them by themselves, but when they're in big clumps together, then it's easy for us to see them. Okay, let's go on to the next thing. The next thing is surface tension. Now, surface tension is an effect that is relative or related to liquid, and it's when molecules join together really strong on the surface of a liquid and sort of create a skin around that liquid. Okay. Now, this is when like molecules are attracted to each other, and it's called cohesion. And sometimes, actually, to be honest with you, you might know this, but water's actually a bit sticky. But anyway, let's keep going. Today, to do our experiment, we will need the following things. We will need a coin, okay? To be honest with you, I'm going to go for the 5-cent coin. You might want to try a 10-cent coin. You need also an eyedropper. Now, you mightn't have an eyedropper, so you could use either a straw, okay, with the good old thumb over the end, dropping out a little bit at a time, or you could use a syringe, okay, so I'll be using those today. Then you will also need a tub of water, which I've got down here. I'm not going to lift it up. I'll show you it later on because we'll use it. We'll also need paper or card. Now, I want the paper or card cut out to a little boat like this if you can. Okay, you can see I've got a pointy front and I've also got, you know, a squarish back, but then I've also got a line cut out in the middle there, and make it a thin line, okay, not too wide. Okay, good. So you need that. Also, you will need scissors. Ta-da! You'll need soap. Okay, so I've got some soap in here. Yep, there we go. There's some soap in there. Also, you will need cotton tips. Now, cotton tips, this is funny, but my wife calls these Q-tips for some reason, but anyway. So there you go. Also, you will need, what else? Disposable plate. Bum-ba-da-bum. Pepper. Really? We're going to eat? I don't know. Pepper. Oh, you also need water. So there's water there. And finally, you will need soapy water as well. Oh, so not just normal water, but you'll need soapy water. Okay, good. So that's got a bit of soap in it. Okay. We know what we need. Let's keep going. Experiment number 1, step number 1. What do we have to do? Okay, so put a coin flat down on a surface. So here we go. I'm going to use the back of this plate, actually. And what I might do is actually stop the video and start to record a little bit closer for you guys so you can see it. Okay, here we go. Okay, so here what I'm doing is I'm picking up some water in the syringe. I'm putting drops in it. How many drops can I get on top of this coin? Whoa, 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 whoa. Oh my God, look at the dome, how it builds up. And that's because of the surface tension of water. The molecules sticking together. Yeah, a little bit more. Oh, there it goes. So that ended up to be around about, 13 to 15 drops until it burst, until the dome burst. Now, on to the next part. Here what I'm doing, I'm putting down a coin again. But this time what I'm going to do is I'm going to use soapy water, water that's got soap in it. How many drops can I get in before or on top of the coin until it bursts? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Oh, 8. Oh, so there you have it. Wow. Wasn't it interesting how the first time we had the coin and we only used water, it formed the dome and we got a lot more drops on it than the second time when we used the soapy water? Well, what was happening here? Well, what was happening here was that basically the soapy water, okay, the normal water, well, the bonds were really strong. The molecules were really strongly packed in together because it was just all water, right? But with the soapy water, it was water molecules, but also soap molecules, which means that sometimes the water molecules couldn't bond together because the little soap molecules were between them. So that's what stopped the strong bonds occurring and thus making the dome possible on the second coin we did with the soapy water, because the soapy molecules were getting in the way of the water molecules bonding. Fascinating. Okay, let's keep going. Okay, so experiment number 1, step 2. Do the same again. Yeah, we did that with soapy water, so we might just keep running through this. I've talked about why it happened. Now, experiment number 2, step number 1. Cut out a little boat, okay, out of your card, which I've already done. So there you go, something like that, okay. And then put a slit in the back, which we've done, as you can see. There we go. And then on to step number 2, put a paper boat in a tub of water, okay, but then also after you've done that, you've got to put some soap in the back of the boat and see what happens. It'll be fascinating. Remember, soap molecules actually break apart the bonds of the water molecules. Okay, so this will be interesting to see. I'm going to stop the video and we're going to have a look in the tub, which I'll get happening now. Okay, good. Let's go. So what I'm doing here is putting the paper boat into the tank of water. Now I'm going to get some detergent on the end of a cotton tip and I'll put it in that little hole and let's see what happens. Oh, look at it take off. Whoa. Man, that went far and pretty fast too. Okay, so that's gone like run out of steam. Now let's try it with one more. Now, interesting enough, we've already put detergent in here, so this I wouldn't have thought it would have worked, but it does a little bit. I didn't think it would work best because all the bonds were already broken, I thought. Yeah, interesting. Wow, so there you have it. Gee, the boats flew, didn't they? Well, what happened here? Well, what happened here was basically that we put the soap in and it's sort of ripped apart the bonds that the water molecules had. So the soap, yeah, was amazing. So all those little soap molecules broke the surface tension and ripped apart the molecule bonds of the water molecules on the top of the water and propelled the boat forward, sort of like a ripping sheet. Cool, okay. Man, I tell you what, that was fascinating. Okay, yep, we'll keep going. Yep, okay, we've talked about why it happened. Okay, experiment number 2. We've jumped a little bit here, but don't worry, we'll keep going. What you need is your disposable plate, so we've got that. And then what you're going to do is you're going to actually make sure it's nice and dry, which I've done by my using my cloth here. Not my cloth, my jacket. Then you get your water, you put that in the top. Okay. Put some water in there. There we go. Right, okay. So I actually might take the camera off. Okay, so what I did here, after putting the water in, I cracked some pepper over the top. And now I'm going to get some detergent and drop a little bit in, and let's see what happens. Whoa! Looks like I've got the force. Well done, OBK. May the force be with you. Whoa! Wow, that was something else. How it just split apart like that. Well, once again, surface tension of the water molecules was broken by the intervention of the soap molecules. Okay, so the soap molecules got between the water molecules and just ripped it apart and pushed out all the pepper. Wow, that was super cool. Okay, so we've talked about that. Let's keep going. Okay, so why does this happen? We've talked about it. Light molecules attract each other, but in this case, a non-light molecules got in between the water molecules and ripped them apart, okay, which has broken that skin of water over the top of that strong skin that we talked about with surface tension before. Now, here you can see next to me, it's actually a soap molecule. Now, water molecules on each end have parts that attract to other water molecules, but soap molecules on one side of the soap molecules, it's attracted to water, okay, water molecules, but on the other side of the, the soap molecule, it's got a part that's not attracted to water. So that way, the soap molecule never really wants to totally join up with water molecules. Okay, so that's fascinating. Okay, so for those who are interested, the part that's attracted to water molecules is called the hydrophilic part, and then on the other side, the part that's attracted to not water molecules but to oil molecules, interesting enough, is actually called the lithophilic part of the soap molecule. Interesting enough, soap molecules, right? When you're washing your hands or you're washing, something dirty, the part of the soap molecule that's interested in the oil actually attaches itself to the dirt and grime, picks it up, and then the other end of the molecule attaches itself to a water molecule, and then you wash it away, and it takes it away. So how fascinating is soap? It's designed actually to pick up dirt and then attach itself to water and then be washed away. Fascinating. Okay, let's keep going. So in summary, we're there. Surface tension is an effect that is actually related to liquid and makes the surface of liquid stronger through the bonding of water molecules. Okay, excellent. Now, apart from that, the soap molecule destroys the bonds of the water molecules and actually splits them apart, breaking the surface water tension or that skin, that strong skin of water around the outside. Fascinating. We've seen that today in our experiments. Awesome. Listen, I hope you enjoyed today. Have a great day and good luck with your experiments. See you next time. Bye. Thanks for watching one of my videos. If you've enjoyed the content or you just want to show your support, please just click the subscribe button down below. You hitting the subscribe button lets me know that you'd like to see more content from me. Thank you very much for watching, and I'll see you next time. Subscribe.